Yes. So this is my 30th video on real analysis in the playlist of UPSC maths optional, and in this video I'm going to solve two problems. So far what we are doing is we have been solving the previous year's question papers on real analysis from UPSC maths optional. So in that way we have finished 2018, 17, 16, 15, 14, 13, 12, and now we are in 2011 question paper, and in that video we are going to finish 2011, and next video I'm going to start 2010, right? So please don't skip this video because I'm going to solve two problems in this video, that is the fourth problem and the fifth problem, right? So don't worry, I have placed 30 here just because that denotes the part of the video, because I'm confused about the which part I'm taking now, so that's why I'm adding the parts also. So the problem 4 and problem 5 I'm going to solve in this video, so please don't skip this video, right? Yes. So if you haven't subscribed our channel, so please subscribe to our channel and you please press the bell icon, then only you will receive notification when I upload a video. I've been uploading 2 to 3 videos regularly daily, so you may miss some video because if you haven't pressed the bell icon. So please press the bell icon, that is right to the subscribe button, that will be right to the subscribe button. Yes. So now we will get back to our problem now, and find the shortest distance from the origin to the hyperbola, right? So we want to find the shortest distance between the origin and the hyperbola. So as I said, whenever you have the find the maximum minimum, we always use Lagrange multipliers, right? So what it says is that suppose if you have a graph like this, so this hyperbola can be of type 1 or type 2, right? So you that not a matter for us. So either it can be of type 1 or type 2. Suppose let us consider this type 1, then this is the diagram for hyperbola, right? So we want to find the minimum distance between origin to the hyperbola, right? So we want to find the minimum distance d from origin to hyperbola. Let us say this point is something here. So this point will be 0 to 0. Let us say this point is x comma y. Now what we need to find is we need to find the minimum distance. So we know distance is square root of x2 minus x1 whole square plus y2 minus y1 whole square, right? So let us say this is x1 y1, let's say this is x2 y2. So if I apply the formula, we have x minus 0 whole square plus y minus 0 whole square, so we will have square root of x square minus y square. So since we have square here, so what I'm doing is I'm going to find the d square, so x square plus y square. So since you have root, so if I have root in the problem, it will be a little hard to find the solution. So what I'm doing is I'm just finding the square. So what I'm going to find is that we have to find the minimum value. Sorry, we need to find the minimum value, right? The minimum distance between, it is not maximum, it is minimum distance, shortest distance between the origin to the hyperbola. This is the shortest distance, right? Yes. So this can also be shortest distance. This can also be shortest distance. Yeah. So what we need to find is we have to find the minimum value of x square plus y square, that is the square of the distance from the origin in the xy plane subject to this condition, right? So what we need to do, we need to find the distance subject to this hyperbola, right? So again I can use the Lagrange multipliers. So I always recommend you to watch the videos from part 1 to this part 30, because we have been solved a lot of problems based on Lagrange multipliers, right? So all the video I can't explain Lagrange multipliers because I explained many times Lagrange multipliers. So if you want more detail, you can go through real 2014 question paper. So in that way we have find the minimum value of x square plus y square plus z square subject to the condition x y z equal to a cube. So here the condition is hyperbola. Here the minimum value you have to find for x square plus y square. So we have two functions. So what we need to find is that we need to form a new function, capital F of x comma y comma z comma lambda is equal to f of x comma y comma z plus lambda times g of x comma y comma z. Now we need to find dou f by dou x, dou f by dou y is equal to 0, dou f by dou z is equal to 0. Then we need to solve these 4 equations to get the value of x, y, z, and then you substitute x, y, z in our function and to check whether it attains maxima or minima. So this I have explained in detail in 2014 question paper. So you please go through this sum also, and please don't watch the video in between, right? So watch from part 1 to part 30. Yeah. So we will move on to our problem now. So it is asked that, so our f of x comma y comma z is, so let f of x comma y comma z is equal to x square plus y square. Why? Because we need to find the minimize the distance. I'm taking the square of the distance. So let g of x comma y comma z is the constraint, that is condition with respect to what? This hyperbola. So therefore this is x square plus 8xy plus 7y square minus 225. So this is our g of x comma y comma z. So we need to find the f of x comma y comma z comma lambda. This is nothing but f of x comma y comma z plus lambda times. You please pause the video and try to solve the problem in your own, right? Because we have been solving many problems based on Lagrange multipliers. So this is x comma y comma z. So our f of x comma y comma z is x square plus y square plus lambda times. So our g of x comma y comma z is x square plus 8xy plus 7y square minus 225, right? Yeah. So what we need to find is that we need to find dou f by dou x is equal to 0, dou f by dou x is equal to 0, and we need to find dou f by dou y is equal to 0, and we need to find dou f by dou z is equal to 0. We need to solve these three equations, right? So we can see it is independent of z here. So we can always restrict our, this will be 0 always, right? Because you can see that our function does not contain x comma y comma z. So not a problem. Let us take the variable to be z, right? Yeah. So our dou f by dou x. So we will differentiate this with respect to x. So we will have 2x. Sorry. So we will have, this will be 2x plus lambda times. So if I differentiate here, x square will be 2x and 8xy. If I differentiate with respect to x, I will have 8y, right? 8y, and there is no x term here and here. This will be 0. So it will be equal to 0. So if I differentiate this with respect to y, so here I have 2y. So here lambda times, so x square will be 0. We are differentiating partially, right? So here we will have 8x. So here you will have 14y is equal to 0, right? Yes. So when I simplify this, I can take 2 common here, right? And I can take 2 common here, and then I can equate this to 0 also. So I can write this as x plus lambda times x plus 4y is equal to 0. I have just taken 2 common and I have just taken 2 to this side, so it will be equal to 0. So again I can take 2 common here. So this will be y plus lambda into, so this will be, if I take 2 common here, I will have 4x plus 7y equal to 0. So I'll separate x part and the y part. So this will be x plus lambda x plus lambda 4y is equal to 0. So if I take x common here, we will have 1 plus lambda plus 4 lambda into y equal to 0. So I take this equation as 1, and this will be y plus 4 lambda into x plus 7 lambda into y equal to 0. So our x part will be this 4 lambda into x, and if I take y common here, I will have 1 plus 7 lambda, right? So 1 plus 7 lambda into y is equal to 0. Now we need to solve these two equations to find our lambda x and y. So first we will find lambda by solving these two equations. So I'm going to solving 1 and 2. So these are just elementary. What I'm going to do is I'm going to multiply the first equation by 4 lambda. So we will have x into 4 lambda 1 plus lambda, and I'm going to multiply this by 1 plus lambda. If I subtract, this term will be cancelled. So I'm going to multiply 1 with 4 lambda. So this equation will become x into 4 lambda into 1 plus lambda plus, and if I multiply this by 4 lambda, we will have 4 lambda y equal to 0, and I'm going to multiply the second equation with 1 plus lambda. So if I do that, I'll have x into 4 lambda 1 plus lambda. So this will be 1 plus 7 lambda 1 plus lambda into y equal to 0. So if I subtract these two equations, what I will have, this part will get cancelled, so this part will be changed to minus. So if I take y common here, so I'll have 16 lambda square, right? This 16 lambda square minus 1 plus 7 lambda into 1 plus lambda y equal to 0, right? So y cannot be equal to 0, right? If y is equal to 0, then we don't get ellipse here. Sorry, we don't get hyperbola here. So our equation will be transformed. So y not equal to 0. So this means this term has to be equal to 0. So this means 16 lambda square minus 1 plus lambda into 1 plus 7 lambda has to be equal to 0. So this means 16 lambda square. So if we multiply this, so we will have 1 plus 7 lambda, and if I multiply lambda, you have lambda plus 7 lambda square equal to 0. Sorry, I'm just facing some issue with laptop. Yes. So this will be 16 lambda square. So I'll just bring minus here. So we have minus 1. This will be 8 lambda. So it will be minus. Sorry. Don't have a proper laptop to record. Yeah. So this will be minus 8 lambda minus 7 lambda square is equal to 0. So if I add the like terms, so 16 minus 7 lambda square is nothing but 9 lambda square. So 9 lambda square minus 8 lambda minus 1 equal to 0. So we need to solve this quadratic equation to find the value of lambda now. So you can do this very easily. I'll do it very fast. So the equation will be 9 lambda square minus 8 lambda minus 1 is equal to 0. So we solve this by quadratic equation. So our lambda will be minus b. So it will be minus of minus 8 plus or minus square root of b square minus 4 into a into c. This is minus 1, right? Because a is minus 1 by 2 into a. So 2 into 9. So this will be minus of minus 8 will be plus 8 plus or minus square root of, this will be 64 plus 36 by 18. So this will be 8 plus or minus 10 by 18, because this will be root 100. So we will have 18 by 18 as one root and minus 2 by 18 as another root. 8 plus 10 is 18. 8 minus 10 is minus 2. So our roots are, our lambda is 1 of the value for lambda. The second value is minus 1 by 9. So the value of lambda is plus 1 and minus 1 by 9. So we need to find our x and y. So I'm going to case this. So case 1, when lambda is equal to 1, what will be your value of x and y? So case 1. So when lambda is equal to 1, we need to find the value of x and y. So for that, you can consider any equations. So I'm considering the first equation. So the first equation is 1 plus lambda into x plus 4 lambda y equal to 0, right? This is our first equation. So 1 plus lambda x plus 4 lambda y is equal to 0. So if I do that, when lambda is equal to 1, this equation will become, so this will be 1 plus 1, right? This will be 2x plus 4y equal to 0. So this means if I divide this by 2, I'll have x plus 2y is equal to 0. So this means x is equal to minus 2y, right? So this is the value of x and y. So when I substitute x is equal to minus 2y, our hyperbola becomes, so our hyperbola is, so given hyperbola is nothing but x square plus 8xy plus 7y square minus 225 is equal to 0, right? This is our hyperbola. So when I substitute x is equal to minus 2y here, so we will have minus 2y whole square plus 8 into minus 2y into y plus 7y square minus 225 equal to 0. So this will be 4y square. So this will be minus 16y square, right? So this will be 8 to 16 y square plus 7y square minus 225 equal to 0. So if I add this, you will have 4 plus 7 is 11. 11 minus 16 is minus 5y square minus 225 equal to 0. So this means minus 5y square is equal to 225, right? So this means y square is equal to minus 225 by 5. So this means y square is equal to what? Minus 45. This is not possible, right? So no real solution exists. So we need to find the real distance between them. Distance between 2 points will always be a real number, but we have to square a number. We should get a negative term that are all positive. So therefore our lambda is equal to 1 is not possible. right? This is not possible. No real solution exists, right? So because we need to square a number, we need to get a minus 1 by s answer. Not all possible, right? Yes, if there is positive symbol, then it is possible, but since we are negative here, no real solution exists. We have only we need to find only real solution, right? Because we find distance, so distance will always be a real number. Yeah, so we will go on to case 2 now. So what will be our case 2? When lambda is equal to minus 1 by 9, right? When lambda is equal to minus 1 by 9, this is our case 2. Now we will see what happens to our equation 1. We can also substitute in equation 2, right? So our equation 1 is 1 plus lambda into x plus 4 lambda y equal to 0. So now we'll substitute lambda is equal to minus 1 by 9. So if we do that, we will have 1 minus 1 by 9 into x plus 4 into minus 1 by 9 into y equal to 0. So if I simplify this, I have 9 minus 1. So it is 8 by 9x minus 4 by 9y equal to 0. So I can take 9 common here and I can bring that to that side. So we are left with 8x minus 4y is equal to 0. Again I can divide with 4. So if I divide with 4, we will have 2x minus y is equal to 0. So this means y is equal to 2x. Now we will substitute y is equal to 2x in the hyperbola. There we have substituted x is equal to minus 2y, right? So now I'm going to substitute y is equal to 2x in our hyperbola. So our hyperbola is so it is 8x square plus 8xy plus 7y square minus 225 equal to 0. This is our hyperbola, right? Yeah. Now we will substitute y is equal to 2x here. This will be x square plus 8x. So I'm just replacing y is equal to 2x and 7y square. So this will be 2x whole square minus 225 equal to 0, right? Yeah. So this will be x square plus 16x square. Sorry. X square plus 16x square plus 7 into this is 4x square minus 225 equal to 0. So if I add these terms, you will have 17 plus 28, right? 17 plus 28. So x square plus 8xy plus 7y square minus 225 is equal to 0. So if I substitute y is equal to 2x. So if we add this, you will have this 4x square. So 17 x square plus 28 x square minus 225 equal to 0. So if I add 28 plus 17, it will be 35, right? So 35 x square is equal to 225. Sorry. 35 x square is equal to 225. So this means x square will be 225 by 35, right? So if I cancel these terms, what I will have? This is 5 sevens are 35. This is 5 fours are 20. 5 fours are 20, balance 2. 5 nines are 45, right? I think I'm making some mistake here. So y is equal to 2x. So x square plus 8xy plus 7y square minus 225. So this will be 2x whole square. Sorry. Okay, right. This is 45, right? I just made some addition mistake. Yes, this will be 45 x square minus 225 equal to 0. So this means 45 x square is equal to 225. So this means x square is equal to 225 by 45. So this will be, yeah, 45 ones are, this is 45 fives are, right? 25 are, or let us go similar way. So if I do that, yeah, it will be x square is equal to 45. 45 ones are, 45 fives are. So this means our x square is nothing but 5. Now what will be our y according to this? Y is equal to 2x, right? Y is equal to 2x. So for x square is equal to 5, y is nothing but 2x. So what will be our y square? It is 4x square, right? So 4 into x square. So 4 into x square is nothing but 5, so which is 20. So therefore y square is equal to 20, and therefore x square is equal to 5. So therefore our square of the distance is nothing but x square plus y square. So therefore 25 is the minimum distance between square of the distance, right? This square of the distance between the hyperbola and the ellipse. So this is the distance, right? So or else you can also now you can, what you do is, if you want to find this square of the distance, if you want to find the minimum distance, actual distance, it will be root 25, it will be 5. So therefore 5 is the minimum shortest distance between the origin and the hyperbola, right? So first we are what we are doing is we are finding the square of the distance. So in order to negate this root symbol, actually then you can find the actual distance by taking the square root, right? So these are very easy problems. So I think you understand this very well. Now we'll move on to the second problem now. So the second problem is nothing but, so I'm not going to prove the theorem I'm going to use. So at the end of, after finishing all question paper, I'll prove this theorem, right? So I'll first quote the theorem, but I'm not going to prove that. If you want proof, I'll just I'll prove all the theorems that I used here, right? After the end of the question paper solutions from 1992 to 2019. After finishing this, I will explain all the theorems. Don't worry, and I also give some lot of questions for you to practice. So it is given that S is a function from 0, 1, and f be a function defined by f of x equal to 1 by x, where 0 less than x less than or equal to 1 is f is uniformly continuous on S. So if you have a function f, so I'll just quote the theorem roughly, that if f is a function a comma b to r, right, then f is uniformly continuous if limit exists at n point. If limit exists at n points, right? So if the limit exists at n points, then the function will be uniformly continuous, right? So for here our f of x is nothing but 1 by x, right? 1 by x. So we will check whether limit exists at 0 and 1. So what will be our limit x tends to 0 f of x? It will be limit x tends to 0 1 by x, right? This does not exist, right? Because as x tends to 0, this will be tends to infinity. So both of them has to exist, but limit x tends to 1 f of x exists, right? Which is nothing but limit x tends to 1 by x, which is equal to 1. So since this exists but this does not exist, both the points it has to exist. So since limit does not exist at n points, f is not uniformly continuous. You have to be very careful about the term between uniformly continuous and uniformly convergence, right? Uniform convergence is for sequence series of functions. Uniform continuous is for single functions, right? Single functions. So I'll just use on this theorem. So I'll give the proof for this theorem after finishing the all question papers, right? So that's it. For the next video we will start 2010. Yeah. So actually I finished 1 decade of problem, that is from 2011 to 2018. So we will go on very quickly. That's it. We'll see in the next video. Goodbye. Thank you.